In this lesson, we are going to multiply and divide rational expressions. Please take a few minutes to record the process. In general, multiplying and dividing rationals is really the same thing, with the exception that a division problem first has to get changed into multiplication. So in order to do that, the operation changes to multiplication and the second fraction reciprocates. The next thing would be to make sure all your polynomials are factored. Just remember, Poly wants to factor. Cancel factors using power rules with your monos, and then binomial factors will cancel other like binomial factors. And again, keep in mind that canceling is numerator to denominator. And then once the canceling is done, you're going to multiply the top, multiply the bottom, and again, we'll generally be writing these just as a product of factors, not actually multiply. In this example, the operation already is multiplication. So then the next step is to go through and factor all our polynomials. So in the first ratio here, this is not a poly, but this is x plus 10. And when we try to factor this, this is already prime. There's nothing that factors out, no GCF, no reverse FOIL, or anything like that. In the second ratio, there's another poly here, 10x plus 30. There is a common factor that can be factored out, and that's the 10 out of the 10x and out of the 30. So this one will involve some factoring. So we're going to start basically a new line of work where we factor out the 10, leaving x plus 3. This denominator is already prime as well. There's no common factor, no reverse FOIL, so it stays as x plus 3. I'm just going to go back and write that first ratio. And now that we're factored, we start canceling. So with the mono parts, here's an example of a mono part. It would cancel with another x that's by itself as a mono. This x is not by itself, this is not by itself, so this x actually has no cancellation involvement, so it stays as x. There's a 10 here as part of a monomial, but it will not cancel with anything on the bottom because there are no monos that can reduce or cancel with 10. So now we're left with canceling out groups that are identical, and that is the x plus 3 with this x plus 3. So those cancel each other out to 1. And that's it for cancellation. Now we're at the step to multiply. So you multiply the top, you multiply the bottom. We get an answer that will say 10 times x, or 10x, over x plus 10. And at this point, we are done the problem. You have to resist the temptation to do any canceling here with 10 or x, because those do not cancel. You cannot cancel parts out of a polynomial to go into a monomial. That just does not happen. So this one's done. This problem begins as a division problem. So the first step is to change that problem to multiplication. So the first ratio does not change. Unless you want to start factoring at the same time, you can do that. But I'm going to work on changing this to multiplication, and then we flip this fraction. We have x squared minus 4x plus 4 all over 4x cubed plus 24x, and that is how you change from a division to a multiplication. So the operation changes and you reciprocate the second ratio, always the second ratio. Now we begin factoring. There are polynomials here, here, and here. So back to the first ratio here. This guy here factors, it reverses FOIL. So after you reverse FOIL on this denominator, you have x minus 2 times x minus 3. And then now we need to factor the numerator here, which again, there's no GCF. So you dive right into reversing FOIL. That will give us a pair of binomials, x minus 2, x minus 2. The denominator has a GCF. It's got 4 and an x. So when you factor out the 4x here, you'll have 4x on the outside and x squared plus 6 in this binomial here. Then you'd want to investigate to see if this factors some more, and it does not. It's not a trinomial. It does not subtract a square number. So the factoring is all done. Now we're going to cancel. So I like to go back left to right, and I like to start at the top here. So 2 here is part of a monomial. It's going to cancel with another monomial part if possible. There's nothing here for it to cancel with, but it does have a 4 here that it can cancel with. So 2 cancels out here, leaving 2 at the bottom here. This is the same as saying 2 divided by 2 is 1, and 4 divided by 2 is 2. We have the x squared here, also part of a mono. That can cancel with this x here, so basically this x is gone. Okay, and then this x squared now is no longer an x squared, it's an x. And then now that the mono parts are done, we're going to review and try to cancel any binomials. So here I have an x minus 2 that can cancel one of the x minus 2's here. The x minus 3 has nothing to cancel with on top. This binomial does not cancel that binomial. They need to be exactly identical for that to happen. So the canceling is done, and we're moving forward with the multiplication. So for the multiplication on the top of the ratio, we're basically just putting it together as one fraction. So x here stays on the outside. It's multiplying to this binomial here. And that's the top. The bottom has this binomial multiplying to this binomial. And again, this is what I mean here by not really actually multiplying it all out. We're going to keep them as factors. So, but we do need the answer to be a single fraction, and leaving in factored form is fine. And here we're done.